All right, so let's look at how we do these reflection problems. So here we've got a problem or a question that says, it's multiple choice. We don't have the options up here yet, but we'll get there. Point P has coordinates 3, 4. What are the coordinates of R, Y equals 1, P? So we have to understand what that means. So let's look closely at that for a moment. R sub Y equals 1 of P. That means R stands for reflection. Oops. There we go. R stands for reflection. And what are we reflecting over? We need a line to reflect over. So we're going to reflect over the line y equals 1. So this is reflection over y equals 1 of point P. Capital P, sorry. Capital letters refer to points. If I wrote a lowercase p, then I might be referring to a line. Okay, so let's do this. So the line y equals 1 is this horizontal line right here. We could put any equation there. We could put y equals 3x plus 7. We could put x equals 2. We could have, right? So we don't have to have a line that's horizontal. We could have a vertical line. We could have a line that's at a diagonal as well. But in this case, we have a nice horizontal line. And we're reflecting point P. So where is point P? It's at 3, 4. 3, 4. So here's point P on the graph. So now the question is, where is P prime? Well, it's going to be across the line and the same distance from the line. So if we look here, we are 1, 2, 3 away from the line. So if we go 1, 2, 3 on the other side, right there is where P prime is. P prime. The prime should be a little bit higher. P prime. That's the notation. It's kind of like it's kind of like an apostrophe. Okay. So we did it. Here are the choices. So this question was designed to be a multiple choice question, and here are your choices for what that point might be. A, B, C, and D. If you were thinking about this and you didn't have a graph to work with, you might think, well, hey, if I'm reflecting over a horizontal line, then one will be directly above the other, just like we saw in the Eiffel Tower picture. And so if this has coordinates 3, 4, if I go directly down from there, my y coordinate isn't going to change. So I can rule out B. My y coordinate, my x coordinate isn't going to change. So I can rule out B and I can rule out D. So it's either A or C. And then the question is, well, how far away from the line y equals 1 is 4? Well, it's 3 away. So you could figure this out. So if we go down 3 from 1, we get C is the correct answer. We can also graph it to see that C is the correct answer. if we draw the line between P and P prime, the line that we reflected over, we can see it's exactly in between P and the P prime. So it is a bisector, and it is also always going to be true that if you connect a point to its image, you will form a right angle with your line of reflection. Now, another way that I could have done this is I could have named this line, and I'll name it M, as in mirror. And then I could have changed this to say, instead of over y equals 1, I could have just said y over M. So that's another way to ask the same kind of question. It doesn't have to be. This could also be written as reflection, and then whatever letter names the line, we often use M because mirror starts with M. So this, our reflection over M of point P, is the same question as what we have in red there. So here are some of the important things you need to know about reflections. Reflections preserve distance, so they're always the same distance from the line. Like you can see here, B and B prime, they're the same distance from the line. The line connecting B and B prime is perpendicular to our mirror line, our M, and these marks here are telling us that those distances are the same. They are congruent, so this is a perpendicular bisector. A reflected image will have all the same angles. So these two triangles, if you wrote out the measure of their angles at A, B, and C, those would be the same measurements for the angles on the other side. And they map. So one-to-one correspondence. C goes to C prime, A goes to A prime. In this case, interestingly, A and A prime happen to be the same because A is on the line of reflection. All right, and so now that we've started to define what the heck reflections are, what kind of notation we use, here you can see they've used the notation R sub M, because this line is named M. We don't have an equation for it, but it's named, so we can use it. Let's look at some of the problems that you're going to do. So here you are going to find the coordinates of each image. So you're given a little graph on the right here, and you get a whole bunch of different things like the reflection over x equals 1 of point Q. So you'll have to draw in the line x equals 1. Just as a reminder, that is a vertical line at 1. So that one would be this line right here. You have y equals -1. That's going to be horizontal. Some of them are reflected over the x or y axis. And yeah, just use what you've learned about reflections to figure out where each of those points fall. And then we'll look at doing more complicated reflections after that.